Once again, welcome to AAAE Symposium, Automation in Agriculture. We want to start the session now, and the first speaker is Dr. Gorantiwar. Dr. Gorantiwar, are you ready? So please go. You have been introduced, but you can again give a short introduction as a Director of Research at Rahuri. Respected Dr. Ganendra Singh, all the dignitaries and all the participants of this symposium. Again, very good morning. I am Sunil Gorantiwar, and currently I am Director of Research at Mahatma Phule Agricultural University, Rahul. And my specialization is as such irrigation and drainage engineering. And that is why my topic is on irrigation water management. As you see, the theme of this year's symposium is automation in agriculture in Asia. So I'll be mainly focusing on this particular theme. You may be aware that what automation does here actually. So automation is something right from practice. No interventions of the human being. Maybe that is for thinking, or maybe that is for decision making, or maybe that is for action actually. So for any process, maybe in agriculture, or for that matter, maybe water management. So if we develop any system, so that have minimum interventions of the human being. So when we do any action, so we think we make certain decision, okay, and based on that decision we make action actually. So in that whole process, if we involve less human being, or maybe no, then we call this as automation. And there are several techniques of the automation. Internet of Things is one such technique. There are several operations in agriculture, and irrigation is one such operation. And, I will be delivering maybe 10 to 12-minute lecture, or maybe my presentation on IoT-enabled technologies for real-time precision irrigation water management. My presentation will be mainly focused on, say, maybe few minutes on what is precision irrigation management itself. Then second is what is the need of real-time precision irrigation water management. Then what are the different approaches for the real-time approach for precision irrigation water management, and the different digital technologies that we can leverage for real-time precision irrigation management, then IoT-enabled technologies, and then what we can do with the help of IoT-enabled technologies for real-time precision irrigation management. Next, please. Next, please. Yeah. As all of us know what is precision agriculture for that matter, we know that precision agriculture, or we can define precision agriculture as the agriculture wherein we apply all kinds of the inputs, maybe it is the natural input or the manufactured input, okay, at right place, right time, in right amount, and by right method actually. So this is what we call as the precision agriculture. And input could be natural input, and as well the manufacturing nutrients and other inputs that are required for agricultural system. I have given here example of how we do the precision agriculture practices actually. If we follow these precision agricultural practices, so this means that applying everything in the right manner, right quantity, right place, then right amount and by right method, then we achieve several objectives of the sustainable agriculture. That is enhancing the agricultural productivity, profitability, then input use efficiency, at the same time as variability and creating near uniform environment. So why we need precision agriculture? Precision agriculture we need for applying the right quantity of the input at right place and all those things. So the challenge is that there is a lot of variability in the agricultural system. And where there is a lot of variability in agricultural system, and if we want to follow the precision agricultural variability. Environment. And secondly, responding to the variability itself to mimic the uniform environment. So first is the cultivation under protected environment. So in this case, we can create the uniform environment and we can remove or minimize the variability itself. But that is under protected structure. But in case of the open field condition, we cannot do this. So in that case, we have to develop the technologies that will respond to the variability or that will mimic the uniform environment. Next, please. Now, as we address how to irrigate, when to irrigate, and how much to irrigate. So, when to irrigate is the right time, and how much to irrigate is the right quantity. So, the first, that is how to irrigate, was addressed, but the rest two issues, they haven't been addressed to that extent actually, and there are certain reasons for that as well. Next, please. Next. The reason is that again the variable. Irrigation water management, the two questions, that is when to irrigate and how much to irrigate. So that we cannot address properly by the traditional approach because of the variability. That variability exists in soil, that variability exists in weather, that variability exists in crop, that variability exists in the irrigation system itself and also the management pattern. So all this indicates that we need to have the farm-specific irrigation water management if we want to address the entire variability. So what are the different factors that are responsible for soil variability, weather, crop and irrigation system variability? I have listed here. Next please. Next please. Then what are the constraints to address this kind of the variability? So this is important actually because irrigation is not something new phenomena. So this has been practiced since ages actually. Since agriculture started, irrigation is also there. But then still, why we are not considering this variability? Because there are certain constraints if we want to address this variability by the traditional method. Because this variability exists with respect to time and with respect to space as well. Say for example, if we consider soil varies from location to location, even soil varies from meter to meter. Then weather varies spatially and temporally. That is, it varies from location to location, and at the same time, it varies from time to time. Daily varies. Crops, we know that it varies from place to place, and as well, crop varies over which crop grows to season. Management practices of each farm or farmer is different. We cannot do. Traditional approach of this entire irrigation management depends on the averages actually, and if we go for the averages, then always the real-time picture deviates from the averages. So it's not possible because of if we adopt if we follow the traditional approach. Next week. Then what to do actually? Okay. So traditional approaches, say for example, weather is there, and whenever we do the irrigation scheduling based on the weather or based on any other thing, then we use the 30 years average data. And as I already told you that 30 years average data send them back all those purpose right from AI, ML, robotics and precision machinery, sensors, IoT, mobile and web-based applications, drones and RSNGS. In morning hours, some of the technologies those were referred as well. But I will mainly deal with the IoT technology. Next, please. So I think by now all of us know that what is IoT actually. So these are the 5 major components of any IoT-enabled technology. Sensor data, or maybe certain kind of vegetation in dice days. So a lot of data we can collect and measure in real time. That is very much important with the help of sensors. Then connectivity is there. So it is not only that measuring the data with the help of sensors. Okay, so it's not something like that we have installed the sensor and go to the field and see what is the reading actually. But then we have to analyze all those things, and therefore we need to transfer this data to somewhere. Whatever the decisions have been taken, that decisions need to be implemented actually. So for that we need certain kind of the activator actually. So these are the 5 typical components of the Internet of Things. Basically, all these are the things, and these are seamlessly connected with each other, and therefore it is called as the Internet of Things. So in case of the real-time precision irrigation management, we can develop the IoT-enabled technology which is based on the weather, soil moisture, and plant water base. So maybe I'll consider one or two. Next, please. So next, please. Weather-based real-time precision irrigation system basically depends on the computation of the evapotranspiration in real time. For weather-based irrigation system, evapotranspiration is the core actually, to the engine of that. And if we want to determine the evapotranspiration in real time means what is today's evapotranspiration. So that is important. And you know that evapotranspiration depends on so many factors. Next, please. Next. So in order to know this evapotranspiration in real time, we have to fetch all the data in real time actually. So unless we bring all this data in real time, it is not possible. And so for that, so whatever is the network available, so that network data has to be fetched at one point and then determine the evapotranspiration. So this is the first our app we develop. We call this as the Pullager. Is picking up the data from certain server, that is IMD or maybe OpenWeather or maybe IBM server. But besides that, farmers, they can be connected to the automatic weather station. They can have their own automatic weather station, or they can also input the data actually. So in this case, we have included one more thing, so which is the automatic weather station. So automatic weather station are weather service provider. So those So we developed this weather-based simulation model behind that. So in which case, farmers need to provide a certain amount of the data, that is crop-related, soil-related, irrigation system-related. So once that data is given, so the parameter that varies in this case in real time are the weather data. So that data is fetched. Then that simulation model informs the farmer whether today the farm is to be irrigated or not. If it is to be irrigated, then for how many hours our pump should be operated. Next, please. So this was just farmer getting the decision actually. But in Internet of Things, when we say that the automation, then our system should be operated automatically and autonomously. So this is very important. So this is the complete automatic or autonomous system for the irrigation system management. So here we don't need any human intervention. Once we record all the data of the farm onto our user interface, then the system is activated, that is the pump or any other system which is. So entire system is autonomous, so thinking, decision making and any action are taken autonomously by this particular IoT enabled thing. So earlier version was based on the time of operation, this was based on the actual water volume. So in this case we added one more thing here, which is the water meter actually. So that water meter was is the IoT. Next, please. So many times we have more than one crop in the field, and the different crops, they have the different water requirements, and we have only one water source. So we need to, and we know that the irrigation scheduling, when we irrigate and how much we irrigate is different for different kinds of the crops. So we need certain provisions at the head of each crop actually. So we installed a solenoid valve, which is also IoT enabled. So and we formulated one system, so we call it as a smart irrigation. So in this case, so we may have the number of crops. So each crop may have the different irrigation scheduling, that is when to apply and how much to apply, and then entire irrigation scheduling is done autonomously, and based on those decisions, if today only onion is to be irrigated for 2 hours, the system will start automatically just for onion crop for 2 hours, or maybe for sugarcane crop, it may be today 40,000 liters of the water is to be delivered, then the water meter will pass only 40,000 liter of the water, and then it will stop. Next, please. Okay, this is just for installation at our farm. Next, please. Okay, so these are the kind of the sensors that we develop, because when we say that the automatic weather station are weather sensors, then those need to be IoT enabled, and those also should pass the data to our system seamlessly. So for that we develop our own weather stations and own what we call as the dashboard. Next, please. So these are the different kinds of the weather sensors. Those who are from irrigation, they know that we can calculate your transpiration by different methods. They maybe hardly someone need only 2 sensors, but Finman wanted formula needs more than 5 sensors. So depending on, we develop the different kinds of the automatic weather station. Next, please. Okay. And many times farmer may not want to spend so much on that, because this weather station costs 1.25 lakhs, and then maybe farmers need something cheap version. Then we develop certain village level, then at village level we know that one automatic weather station evaporation. So we also develop the IoT enabled time evaporimeter. So instead of IoT enabled AWS, the IoT enabled time evaporimeter is connected. Next week. Okay, these are the pump controller. Next week. This is the solenoid valve which is IoT enabled. Next week. Water meter which is IoT enabled. Next week. Then the next is soil moisture sensor based. So in this case, the IoT enabled automatic weather stations are weather sensors. They are replaced by the soil moisture sensors, and soil moisture data is being recorded on daily basis. Current level to the field capacity. So that entire thing is calculated. There is a particular DSS software. So only thing is that the thing is instead of weather sensor, there are soil moisture sensors. So we develop various kinds of the soil moisture sensors, IoT enabled, capacitance based next week. FDR plus capacitance based next week. Thank you, Dr. Gorantiwar. Thank you very much. In fact, friends, we have invited a good number of students from MGM, from Parvani, from Badnapur, and other places. So I would request the presenters that, like industry presenters, should not focus only on their product and just give it in a flash to the advertise. It's not like that. So if you have, and whenever I visit my students in the hostel and their class, they are, many of them are farmers son and daughter. कहते हैं होता कहाँ लगता है सब चीज जो आप प्रेजेंट करते हैं, ये कहाँ आपने छोड़े, कहाँ लग रहा है. तो अगर आपके कुछ फील्ड एक्सपीरियंस है तो उसको जरूर इंक्लूड करें. फार्मर्स फील्ड पर, एक्चुअल फील्ड पर, कहीं पर आपके एक्सपीरियंस है, क्योंकि that will instill in their mind that these technologies, they will be the carrier to take. And we invited them with a purpose, and AAA took a decision that we will invite all these students without any registration charge. Just curiosity. Because we want. So that was the decision, and we discussed with Professor Gajense, and we have been doing in ISA also. In fact, we started giving TADA also to the students because we know that they are the future of agriculture, old profession. So keeping that thing in view, please, even if it is not in your presentation, do talk about something which you have, field experience actually on a farmer field or your own research farm. Then you try to consider this. Here we have that. So that will be, very, very, useful for the whole of the audience and particularly the students. Thank you very much. And now I invite Engineer Neeraj Kumar Srivastava. He is my best friend, teacher classmate, and he was the joint director engineering in UP, and he has served the whole life with a farmer. Engineer Neeraj Srivastava. Thank you, Dr. Gajense. Dr. Gajense, Dr. Gajense, and all the dignitaries present here, and all the participants. Basically, I am just doing money to introduce me. I am here for retired from as joint director engineering from the Agriculture Department UP after 34 years of service. As Dr. Gajense was saying, that I am retired, not tired. So I have again become the student. I just joined postgraduate diploma in business management from Symbiosis Institute of Distance Learning. I just received my student ID card of 1 month back. Now I am in a dilemma. If I book the flight, there are two options: senior citizen, student. Which one should I go? I have been serving in the farm mechanization before my retirement. I was implementing 2 schemes and crop residue management. So I will talk on that. Actually, as Dr. Inmani was saying, I should share the field experience. So I will share the farmers' difficulties and experiences. Actually, UP is land of small and marginal farmers. It has got 92% of small and marginal farmers. So all the planning in Uttar Pradesh is done of this booking. Some dealers took advantage of this. What will they do? They will put a lot of computer in their office and book on the behalf of farmers. So they started taking money from the farmers that we will do the booking. Because in the majority of the equipment, booking just got over in 5 to 10 minutes. So farmers were not getting it. And secondly, and in the when that equipment was verified with the district level officials and the photo with the farmers was uploaded on that. What was happening in practically was felt that certain dealers gave the bogus billing without the supplying the equipment, and that bill was uploaded. When officers went for the verification, the equipment was not found. So farmers will want the time. Sir, give me one week time or 15-day time. We will get the also. And every manufacturer was asked to upload the inventory of the equipment supplied to the dealer, and the dealer was asked to upload details of the farmer to whom he supplied the equipment. When the official went in the field for the verification of the equipment, so and this practice was put on the check. And I think I was instrumental for this portal, and everything was done by me, and I was successful in getting this Lakna removed. Next, next. Daily pollution is very high. So Supreme Court entered into it. They called our chief secretary, and then they were going to put the ban on the construction work. So immediate advocate jump. They said that there is a lot of burning of the stubble. That also causes pollution. So our chief secretary was called. All the three states, Punjab, Haryana, and Uttar Pradesh chief secretary was called. They were just reprimanded like anything. Then the government of India launched a scheme, craft residue management scheme. For this, they introduced 14 special equipment for the stubble, and yeah, on the 50% subsidy. And then they are again introduced farm machinery bank of the 15 lakh. Then the central government decided to get away with the farmer society. Next year, sir, they stopped the farmer society and we made strict rules for the FPOs. Like they should be 3 years old, 300 members should be there. There should be uh, uh, payment of they should have. So it came into the stock. It got checked, and now everything is normal. Yeah. No, automation picked up. In the last system management equipment. So, yes, sir. It should be used with the super SMS. And if any combined harvester found without super SMS, then it would be seized. Last year, I think we seized around 80 combined harvester without super SMS. So they were given subsidies to buy for the rotavator. They go for rotavator. So the equipment purchase was high. Then central government stopped the purchase of rotavator in the CRM scheme. So it went down. Total farm machinery banks were 922 were given to the panchayat. Supreme Court in its hearing said that we should strengthen panchayat and farm machinery bank should be given to the panchayat. What happened in the first year of Supreme Court decision? We gave we selected 922 panchayat. The equipment, it considered it to be his property, and it was not transferred to the next Gram Pradhan. And secondly, there was lot of bargaining from the dealer also, how much commission you will give, how much. So I got many complaints on this. So we did the verification, and from the next year I stopped giving the equipment to the panchayat because there are a lot of complaints. Getting at 80% subsidy, so tractor has picked up a lot. It was based on my field experience. I wanted to share. Thank you very much. Thank you. Thank you very much, sir. I'd like to request Nirmani, I think you should give him an appreciation also. Nirmani, my batchmate, classmate, line mate also. I'd like to request Kaushal Jaiswal. Okay. Mr. Joseph Jaiswal, introduce yourself briefly and then the presentation. Thank you. Good afternoon, everyone. My name is Kaushal Jaiswal and I am representing a company called Precision Irrigation. And my sincere thanks to Dr. Indramani and Dr. Gajendra Singh for inviting me and giving me the opportunity to present you the technology which we have patented globally. And hello, you started and saying so I graduated from Pantnagar University. And I am not an agriculture engineer. I am agriculture, BSc agriculture, and then I did my post-graduation from there in plant pathology. And I started interview itself, and I started working in the space of chemical fertilizers and the pesticides. Then I moved to a company called Chambal Fertilizers, which was in again urea manufacturing company. From there, I moved to a company called FMC, which is a global giant in the space of chemicals, and I was working there in the crop protection division. Then I moved as a CEO of Zuari Rotem Specialty Fertilizers. We used to manufacture the water soluble fertilizers. Then I moved to Zuari Seeds, worked in the space of the seed manufacture, seed production, and the seed marketing. And from there, I moved to a company called Precision Irrigation, which is an Israel-based company in water management. So this is my career. So I have worked in all space of agri input side, from the crop protection to have a challenges in the water management side of it. So next slide, please. So what about mana? I'll give you what is the mana irrigation. Mana is basically a Hebrew word, which is a fruit from, meaning from the fruit from heaven. That's how the mana word is derived. And Revolut launched mana irrigation in 2016. And in April 2023, please go back. When there was a merger, the merger happened between the Jain irrigation and Revolut globally, and that with this merger, Revolut acquired the Jain international business globally. And with this, we merged the Jain logic, which was the IoT-based system, and the mana irrigation.
50,000 hectares of the land and providing the advisory to the farmer about the irrigation recommendations. Next, please. Little bit about the parent company. We are the second largest company in the space of the micro irrigation globally. We have over 50 years of experience. We have a global presence in 120 countries. Around 22 factories globally, 3 R&D centers, and more than 3,000 employees working all across the globe. Next. So what is the challenge? The challenge is to find an optimal irrigation schedule for the best water use efficiency. And for the student purpose, when I am talking of the water use efficiency, I am talking about the per. So when and how much? What happens? There is a yield is one side, water usage and cost is the other side, right? So next, please, President. So when you under irrigate, the stress of the plant is there and it is not yielding much to the potential. Next. And when you are over irrigating, like drip irrigation, how the drip irrigation is being used in India, though it gives you a water use efficiency of 95% and more, but in India, mostly the drip is being used as a flood irrigation. Farmer switches off the motor whenever there is a power supply, and that pump keeps on running for hours without anything. Use rather than use efficiently. How to control it? Next. So, what are the available irrigation scheduling? Next, please. Keep on proceeding. There is a traditional method which is not very scientific, and there is a room for optimization. It's on the gut feel. Next, please. Keep on proceeding. Next. That's all. Hold. So then came the ETC table, evapotranspiration table, not very specific to the field, outdated information. Then when doctor was talking about the soil and plant sensors, so you need the sensors, you need a capital expenditure on the field, and there are challenges, logistic challenges are costly affair. So now we have moved from the soil and plant sensor to the hardware-free whole field irrigation intelligence, which is based on the remote sensing. How does it work? It provides a hardware-free daily irrigation recommendation and crop monitoring for the better water use efficiency. Number one, no hardware on field, no capital expenditure, no capex, nothing. And it's operationally very, very cost effective. Optimal irrigation schedule decisions save cost on the water and energy, increase yield, and you can use this technology for remotely monitor your field as well. Next. How it works. I will not go into the details of the agronomy, but basic estimate from water. No, you need not to do a video. There is a separate video. It is on the YouTube, so don't go by that. I have given a next video slide separately. Just let me finish the presentation, then we'll play the video. So how do we measure it? It is based on the NDVI index, which is called Normalized Difference Vegetation Index. So how do we measure vegetation? More vegetation, higher water consumption. Next, please. Next. So if the NDVI is 0.4, that means low water consumption and low vegetation. If NDVI is 0.6, mid water consumption and mid greenery, and NDVI is more than 0.75, that's higher water consumption. That's how we are using the NDVI index for the measuring the requirement of the water. Next. Again, I'll not go into the details of that, but what we do is we calculate the KC by using the remote sensing. We are not using the KC published by FAO, right? It is on the real-time data basis. So KC calculation on basis on the remote translation calculates the actual observed KC by a representative vegetation. KC is a for the people those who don't understand it is a crop coefficient which gives you a exact water or maybe the peak water requirement of the crop at a particular growth level, right? So this is how we calculate it. So, and what we are doing is we are using the different satellites. We are using Landsat-K, we are using Sentinel-2, we are using Planet Scope, and we are using Sentinel-1, which is a radar which is able to penetrate even the cloud cover. But it's a costly affair. If you and I keep telling people when there is a cloud cover, why do you need an irrigation recommendation at all? But sometimes if it is required, there is a possibility of giving you there. Next. And you can integrate the MANA software if you have a local weather station on the field. Otherwise, we are using the weather station for the hyperlocal weather forecast. But if the farmer is having his own local weather station, it can be integrated with that to calculate the hyperlocal weather forecast. So generally what happens, what we are doing, I will try and explain it to you. We are using remote sensing. We are using hyperlocal weather forecast. We are using the KC table which we are generating, or sometimes using the KC table published by the universities or published by the FAO. Merging these three things together, there is an algorithm at the back end which gives you an exact water requirement of the crop at that particular day or maybe in the coming week. And then we are pushing that information to the farmer on his smartphone and asking him to irrigate his field according to that. And we are using the hyperlocal weather forecast of the 3 into 3 kilometers per square, 3 kilometer square area for that hyperlocal forecast. And then we are giving a farmer an option if there is a slight variation in the weather forecasting or something like that, he can adjust that on his mobile and get a right recommendation. Next. Next. So we did a industrial potato trial in India in collaboration with the PepsiCo, and you will see that what happened. The water saving was recorded with farmer practice, 35 to 43%. Irrigation use efficiency was improved 84%, and yield increase was recorded. Identifying the parts of the field that were over or under irrigated. Sometimes what happens when you're particularly in the sugarcane field, when after a stage, it's difficult to enter inside the field. But when you have a crop monitoring images, you can always see that on your mobile that which part of the field is under irrigated or over irrigated. You can sense that. Next. These are the yield increase is, you can imagine, 72 tons have gone up to 120 tons per hectare. And irrigation use efficiency also have gone up from 5.1 to 8.1. So these kind of differences we can bring in just by optimization of the water use. Next. This is a sugarcane experience again, the farmer practice versus mana practice. What are the features? It gives you the irrigation scheduling, and it gives you irrigation scheduling for 1 week, next day, how do you want to schedule your irrigation? Next. And it gives you a lot of many more data, which as a scientific community we can use it. It gives you PTC, it gives you the vapor pressure deficit, it gives you the rainfall data, it gives you a last 10 years data, it gives you a next 15 years data. So there is a lot of data available on that particular field. But that too in his own local vernacular language. Farmer doesn't understand the millimeter cube or the centimeter cube. So what we did is, since we considering the discharge of his pump, we give him a recommendation that 30 minutes operation, 1 hour operation, 2 hours operation. And considering two things, what is the irrigation method? Because it is using a sprinkler irrigation, we can use it. We consider the irrigation efficiency of the irrigation method at the back end, and algorithm gives you an artificial intelligence, takes it over and gives a right amount of the water at the right time. Recommendation. Thanks. Next. So this is some of the crop monitoring tools. It gives you a crop vegetation, it gives you a crop wetness. Go and monitor those fields physically. Next. It gives you the ADC map. Next. And lot of crop monitoring. Vegetation, relative vegetation, absolute vegetation. Next. And it gives you a plant wetness and map as well as the vegetation variability map. What we say to the farmer, if it is the same, then it's the irrigation related issue. But if it is not the same, the plant wetness is saying something else and the vegetation variability is something else, we ask farmer to please end up and go to the field and check whether it's a nutrition deficiency or it's a crop protection issue or whether it's a disease and pest management issue. It's definitely not an irrigation issue. Next. Yeah. Can you figure out that? Yeah, मैंने एक सुपर presentation दिया था. So 2 minutes, not more than 2 minutes. You are very precise, doctor. You are at the dot, on the dot. In the meantime, I request Dr. Amrish Kumar to give a general appreciation for any. This one, sir. These are both These are both Pantanagar alumni, so that's why I picked up. मैंने सुबह किसी के लैपटॉप पे लोड की थी लैपटॉप कैलाश देखिए 2 मिनट के वीडियो के लिए भी टाइम ज्यादा लगेगा तो आप अपनी एफिशिएंसी कैलकुलेट कर लें. And the result is Mana 2.0, taking irrigation scheduling and crop monitoring to From now, growers can monitor every part of their field on a Mana irrigation. And the result is Mana 2.0. Listen to our customers. We listened and analyzed. Listened and developed. Now, listen to monitor every part of their field. And the result is Mana 2.0. Taking irrigation scheduling and crop monitoring. And the result is Mana 2.0. So now, growers can monitor every part of their field on a daily basis to develop. Now, growers can monitor every part of their field on a daily basis now included in our standard operations. On top of these, we've got like these added capabilities to trace farm operations. I think we should stop the volume. No, over 2 kilos. Okay. Well, thank you very much. Give him a big hand.
Uh, Mr. Jaiswal, we request your company to give internship to the students to work in the field, and you have to provide them a kind of a assistantship in the sense the accommodation and little bit of support of the food and all this, so they stay comfortable. Okay, so this is.
We will consider it, but we do give the internship, and it's more of a field internship.
Yeah, so that's why accommodation and food at the field level is very important.
No, no, that's what I'm saying. We give an assessment, but it will not be at one place. It will be here and there.
Very good, because we want to be as practical as possible for all applications. Okay, thank you very much. He's a professor at the Indian Institute of Technology, Indore, and he's a big boss in government. I don't know, he will explain. Huh? So, Ganti, and give your introduction, okay?
Good afternoon, everyone. So my name is Gorantiwar. I'm a professor at IIT Indore, and right now the national coordinator for the Indian Knowledge Systems Division, which is a independent division of the Ministry of Education. With regards to the global population, energy, whether we talk about climate change, health, and whether we are talking about plant health, animal health, or human health, all of those things, and information exchanges, and then the global order. We can't ignore the politics and the geopolitics of the whole thing. So these are all the mega trends that are going to govern. And what is a mega trend? Mega trend is something that is so big that no individual person, community, or country can control. It is something that is like a Jagannath, Jagannath Rasa. Once it moves, there is nothing that can stop it. These are some of the mega trends that are going on. Next slide, please. Next slide, please. Yeah. So, biggest existential challenge that we are facing is how do we feed a population of 10 billion in the next 25 years? We are talking about Amrit Kaal in India. 25 years will be a great place of churning and all that. But essentially, development, path to development, that is very aspirational and very important. But also concerning at the same time is that we are also going to be in a world of 10 billion with increasingly shrinking resources. How are we going to feed them? In a very good place right now, despite four-fold increase in our population from 33 crores around 1947 to 1.4 billion today, and all the problems that we had in 1960s in terms of starvation and all the kinds of problems. Today morning we had basically paid our respects to great Dr. Swaminathan, who who helped us with the Green Revolution, which actually made India self-sufficient. Because the independence of a country, the first expression of that is ability to eat food and produce our own food and control the food production. And so, despite the fourfold increase in the population, we are in a good place today. And India is also not just a big country. Although we are only 5% of the land area, we have the 5% of the land area. We have 12% of the biodiversity. It's a biodiversity hotspot for the whole world. So all of these things that we talk about, climate change, all of these things will impact us in a big way, and these have ramifications not just for our country but also for the whole world. And of course, we all know that the green revolution had come with a lot of costs. We are all aware of depleting soil organic carbon, increasing use of fertilizers, nutrient leaching, groundwater pollution, depletion, overuse of pesticides, loss of biodiversity, and so on, and most importantly, loss of seed security as well. These are all the consequences and some of the unintended consequences of the green revolution. Next slide, please. And we always talk about sustainability. But my fundamental question, today my talk is going to be kind of provoking you to think about these things. When we talk about the trajectories that we are moving, they are inherently unsustainable. That means the rate at which we are consuming the resources, the rate at which that is already on an unsustainable track is something that is going to be very, very important for all of us in ag engineers, especially ag engineers, to think about. And because you can see many of these boundaries, planetary boundaries have already been reached. Few years ago, there were only 3 of them that were reached, and a 5-year update, all of them, many more have been reached. Next slide, please. And this is a question that I want to pose to you. Crop production today. I'm not talking about milk, I'm not talking about vegetables, I'm not talking about fruits. How much time do you think we will have before we run out of grains to feed the world? Any guesses, students? How much time do you think we have? If I stop crop production today, how much time do I have just to talk about wheat and rice? 90 days. 90 days. Imagine that. Essentially, that is one cropping season. That is all the flexibility that we have. A lot of the optimization that we have done, the global network that we have created for efficient exchange of goods and economic trade and these things, has led to something called loss of resilience in the whole system. That is, like, as if I had 2 kidneys and I have lost one now. I'm functioning on 1 kidney only. And what does that make us susceptible to? It makes us very susceptible to things are globally connected. A drought or a war in Ukraine is going to impact us. A drought in Australia is going to impact us. Midwest of US, if their corn production goes down, it is going to impact us. All of these things are very, very interrelated. So we are becoming more and more fragile. We are losing resilience in the entire system. Although it may seem that we have increased the production, we are even at a small changes in the next slide, please. And why is that important? We are talking about climate change. And all of these things, as adding this, we already know that the seasons have shifted and things like that. What is the popular perception? It is that if there is a current state of these green, lush, green forests, when it changes, it becomes like that desert. It doesn't happen in one day. There are cycles. There are cycles of fantastic book by Professor Nassim Nicholas Taleb. You must have read a book by his book called Black Swan. Very popular book about managing risk. And he wrote another book called Fragile, Anti-Fragile. So what is anti-fragile? Essentially, it is systems that inherently increase the resilience. They're not just resilient, but increase the resilience. And look at systems that have been functional for thousands of years. Because if you look at a agriculture system that has been practiced for thousands of years, then what is it? They must have gone through multiple cycles of drought. It is not an impossible thing that they would have not seen a 10-year drought or a 12-year drought or floods. And they must have developed all kinds of strategies to next slide, please. So this is a photograph of cave paintings in Tibet, which are very near to my place, near Bhopal. So it's a more than 35,000 years old cave painting. And people have been living in that Narmada Valley and then these areas for a long time. And if you look at archaeological evidence, I'm not talking about textual evidence, I'm talking about archaeological evidence of agriculture in India. It goes at least back to 10,000 years. That is the end of the last ice age. Since then, we have had continuous agriculture in India. And the first year of domestication was about wheat, then barley, then it came to smaller like millets like ragi, then we had probably around 4,000 years ago, 3,000 years ago in India. That's when it was domesticated. Probably simultaneously it was also domesticated in China too. And if you look at the textual evidence of agriculture, even the earliest of the Vedas, which is the Rig Veda, the Kshetra Sutta is specifically about agriculture. That is where Arvatis Vage Ghosh Sita Vande Vanda Mahetva. That is where the word Sita. Sita is essentially nothing but the plowshare, the sharp end of the plowshare. And that's where it occurs. And then if you look into Bhruguvalli, and I see that even the Devakya of this university is Annam Bahum Purvita Tadvratam. produce more food. That may not be your vision in life. Annam brahmeti vyajanat. Annam na India. Do not disparage food. Annam na parikshita. Don't waste food. Don't disparage it. Produce a so that you can distribute it to others. This is the biggest service that we as agriculture engineers do to the society. Even if you look into 1900s, for every 92% of the population was involved in agriculture. Now we are only 2 people, 2%. This is what leaves other 98% to go and invent their Apple, iPhones and all that stuff. We don't do our job, they will not be able to do our job. This is so there are several verses like this. And then I want to point out another thing from the Chamaka Prashna of Krishna Yajurveda. There they say, Kuyavaschame, Annamchame, Akshashame, Vrihayachame, Yavaschame, Mashachame, Tilaschame, Mudgaschame, Khalvaschame, Godhuvaschame, Nivarachame. These are all names of the Greeks. And if I wanted to look into 3 of these things, Vrihi means any variety of rice. Anvaha means the special rice, that normal rice, domesticated rice that we use. And Nivara refers to the wild rice that is available. If they were able to do this thing at the time of Krishna Yajurveda, you can think about all of this, how antiquated the agriculture in India is. Why am I mentioning all of this? I'm making a point that the antiquity of the agriculture every 400 years, 500 years, there have been texts. And not just in Sanskrit. They have been in Malayalam, they have been in Kannada, they have been in Farsi. You can actually find it in all kinds of languages across all countries. And it's not just a theoretical discussion. They talk about plowing, furrowing, specifically furrowing, seeding, cultivation, irrigation, weeding, harvesting. How do you classify crops? And all of these things, how do you manage pests? All of these things indicate a very high level of expertise in agriculture. Next slide, please. Who sent these gazetted notes to Britishers back home from India in around 17th and 18th centuries? What they were finding was that there were different types of plows in India for different types of soils. Traditional plows, very different, and they were only tilling 5 to 10 centimeters. That is what we call these days as reduced till and all that. And they were light and optimized for the drudgery of both animals and the people. Whereas they were very different